Hello everyone, I'm Kamal Noori and here is Remote Sense Geosciences channel. Today I want to talk about satellite sensor. Please follow this session. But what's a satellite sensor? In the remote sensing, a sensor is a device capable of receiving and recording electromagnetic waves. According this slide is showing simplified structure of satellite, include platform, battery case, polar solar panel, and sensor. Space platform is different sensor. This slide is showing VNIR, TIR, microwave, radar, or laser sensor in space platform. This slide is showing sensor types. There are two types of sensor: passive sensor and active sensor. Passive sensor include non-scanning and scanning. Active sensor include non-scanning and scanning. This slide is showing sensor types, include passive sensors or optical remote sensing, and active sensor or LiDAR or radar remote sensing sensor. In passive sensor, electromagnetic waves produced by the sun, and the active sensor, electromagnetic wave produced with platform or with satellite. This slide is showing optical remote sensing and SAR remote sensing. SAR means synthetic aperture radar or active remote sensing. In optical remote sensing, usually electromagnetic waves produced with the sun, and in the SAR remote sensing, electromagnetic waves usually produced with satellite or platform. But this slide, types of sensors in terms of data collection geometry. 1. Point type or whisk-broom sensor. 2. Linear type or whisk-broom or wishbone sensor. And number 3, frame type or strain sensor. On the left, you can see whisk-broom sensor, and on the right, you can see steering or frame type of steering sensor. Frame type or steering sensor, and push-broom or linear type of remote sensing sensor. Sensors specification. In this slide, we can see 3 specifications. Number 1, FOV or field of view. Number 2, IFOV or instantaneous field of view. And number 3, resolution. But what's field of view or FOV? The field of view or FOV is the angular extent of the observable world that is seen at any given moment. In the case of optical instrument or sensor, it is a solid angle through which a detector is sensitive to electromagnetic radiation. In the slide, we can see FOV and IFOV. FOV determine swath width of satellite track. View of the MSS viscount scanning geometry and image projection for Landsat 1, 2, 3. FOV or field of view in Landsat 1 equal 20 degrees and swath width in the track equal 185 kilometers. But what's IFOV? What's instantaneous field of view? A measure of the spatial resolution of a remote sensing imaging system, defined as the angle subtended by a single detector element on the axis of the optical system. IFOV has the following attributes: solid angle through which a detector is sensitive to radiation. The IFOV and the distance from the target determines the spatial resolution. A low altitude imaging instrument will have a higher spatial resolution than a higher altitude instrument with the same IFOV. So, IFOV or instantaneous field of view determine pixel size or cell size or spatial resolution according to this slide. But this slide, sensor resolution. There are 4 resolutions for each satellite. Number 1, spatial resolution, pixel size. Number 2, spectral resolution, equal band number or numbers of band. Number 3, radiometric resolution or bit depth. And number 4, temporal resolution or time resolution. Orbital period or return rate. But this slide, spatial resolution or grand resolution. In this slide, we can see fine spatial resolution to coarse spatial resolution. In fact, pixel size determine fine resolution or coarse spatial resolution. This slide, spectral resolution or number of band. This slide is showing Landsat 7 and Aster number bonds. For example, Aster sensor has 14 bonds and Lancet 7 has 7 bonds. So the spectral resolution of Aster is higher than of Lancet 7. And this is slide. Radiometric resolution. Radiometric resolution is the ability of a satellite sensor to detect and distinguish between different levels of reflected or emitted radiation from the Earth's surface. It refers to the number of digital values that a sensor can use to represent the intensity of the radiation it detects. This slide is showing radiometric resolution and bit depth. Top 0 to maximum radians equal 255 and below 0 to maximum radians or 1000 or 95. So the below part is highest radiometric resolution. And this slide, temporal resolution. Temporal resolution in remote sensing terms is the time that has elapsed between subsequent image capture of the same landscape features by a remote sensing. For example, Lancet 5 characteristic. The temporal resolution in Lancet 5 is equal 16 days. Another characteristics, inclination, time of day, ground track, satellite orbit, orbit period, and altitude can be seen in this slide. And final slide of this session. Many thanks for your attention.